Hello everyone. Welcome. Welcome to the Ethereum Nigeria. Welcome to the Ethereum Nigeria meetup. Road to Devcon Bangkok. And today we'll change safe and it'll be teaching us how to build Web3 plugins to win bounces. But first, I would like to thank the ecosystem partners, Web3JS, the file builders of Eat Accra, Eat Safari. Thank you for the support. And if you want to follow up, if you also want to follow with the discussion, you can join the community Telegram channel and you can also follow discussion on Twitter. So now we'll be having Santiago as he takes us through how to build Web3 plugins. Thank you.
Okay, amazing. Thank you so much, Ese, for the intro. Can you hear me properly? I guess. Can you hear me, Belen? It's fine? Okay, perfect. Yeah. So what we are going to do today is you will learn how to build Web3.js plugins. This will help you to normally apply for bounties or different grants or even just kind of win hackathons. What I did like a few months ago was for it Tallinn in Estonia, I built a Web3 plugin for a specific use case that they were kind of looking for, and then I won. So yeah, that's something that will really help. That's something that will really help you to at least get the tools and the knowledge to build any developer tooling for any Web3 project. The specific case that we are going to do today is to interact with the JSON RPC API. That's fine. Yeah, we are going to interact with the JSON RPC API of different layer 2s. Who from here doesn't know what is a JSON RPC API? Everyone knows what is the JSON RPC API? Everyone knows what is the JSON RPC API? You know? You know? Yes, you know? The guys there, they know? Do you know JSON RPC API? Do you know JSON RPC API? JSON RPC API allows you to, it's like the communication protocol. It's a communication protocol that so you're interacting with you're basically sending requests that is a JSON RPC API. So we are going to interact with Perfect. So here, what we are going to do, you can see it in the slides. What I have Zoom call, not there with the light. In the Zoom call, the JSON RPC API is like the first thing that we see on top. So that's what we are going to send when we are interacting with Ethereum or any EVM blockchain. We need to send these JSON RPC requests. But then using the Web3 plugin, you can send what we have at the bottom of the slides. Basically, just one JavaScript line of code. Okay, so this is the agenda for today. We are going to start with a short intro of Web3.js. Then we are going to build like a Web3.js plugin. At the end, maybe I will show you some existing plugins that we already have. Okay. Okay, so for those who don't know what is JavaScript, Web3.js is basically an abstraction over the JSON RPC API using JavaScript. So you will be able to interact with Ethereum or any EVM blockchain using the lines of code that we see under here. So you just need to import the Web3 library. Then you need to initialize the Web3 library Web3 module with a RPC endpoint. And then after that, you will be able to use the Web3 library instead of sending these JSON RPC calls. Same here, when we are interacting with contracts, we need to send these long JSON RPC calls, but then using 3GS, we just need to send basically these lines of code that you see here. We initialize a contract with an ABI and an address, and then we are able to interact with the contract, in this case with the ERC20, instead of sending these long transactions. This is the structure of the Web3.js library. So basically we have the main Web3.js library on top. When you run npm install Web3, you are installing all these different modules, the Web3 ETH accounts, ETH contract, ETH DNS, also this whole Web3 ETH, Web3 utils, etc. Or you can also import and install one by one, depending on what you need. Raise your hand.
Yes. Sorry, can you go over the JSON RPC API again? The JSON RPC API, please can you explain again? I don't think we got it.
So basically the JSON RPC API is let's say the language that Ethereum uses to interact with the Ethereum virtual machine. So that's why in this example that I have, when you are getting the block number, you need to send this thing that you see on top. That's basically what you are sending to the Ethereum nodes, and then they will return the latest block number, right? But then using Web3.js, you just need to use the thing that you see under. You import the Web3 library, then you initialize the Web3 library, and then you can use the Web3 library, right? But then the JSON RPC is the language of Ethereum. Let's say like that. Or any EVM blockchain, they always use this JSON RPC protocol, and also even other blockchains like Solana or Polkadot, they also use the JSON RPC API. So that's the language, the communication protocol that they use to interact with the blockchain. Yep. Perfect. And then Web3.js is just an abstraction of these JSON RPC calls in JavaScript. That's basically Web3.js. So here in this example, instead of sending a transaction with these lines of code that you see here, we just use Web3.js like that. But then under the hood, Web3.js is sending this JSON RPC call that you see on top. Perfect. Yeah, this is the dApp communication flow. So Web3.js will be in the front end of the application, or it can also be in the backend depending on your needs. Web3.js will connect to an RPC endpoint, or it can also be injected provider if you have it in the front end, so it can connect to MetaMask. Then the RPC endpoint or the injected provider will be the one that it will interact with the blockchain network, so with the nodes, and then it will execute the transactions, or it will retrieve data, depending on what you need. Remember that Web3.js is also compatible with all the EVM blockchains, EVM networks like Zillow, Avalanche, Polygon, Optimism, etc. Okay, and then this is how we use Web3.js. Who from here has never used Web3.js? To know if I should give an intro of Web3.js? Or should I just, no one? Okay, perfect. So then let's start with the intro of Web3.js before we jump into building a plugin that is a little bit more complex. So the first thing that I'm going to do is to create a new folder. In Nigeria. Okay, once I create the folder, I'm going to create a node project by typing npm init-y. Then after I create the node project, we can see the package.json here. And then we can install the library by running npm install web3. Then it's loading. Perfect. So then you can see that we have the Web3 library installed here. And then I will just create like a index.mjs file to get started with the library. So everything that I'm going to explain will be in the slides. Actually, I will need to add some of the slides for the intro because I would just brought some things to build the plugins, but then I will just do, I will add the slides to kind of introduce you to Web3.js as well. So the first thing that we always need to do is to import the Web3 library. So to do that, we just need to type import Web3 from Web3. Then we need to initialize the RPC endpoint. To initialize the RPC endpoint, we just need to put here a URL. Let's put this a little bit bigger. We just need to put here a URL. So this URL can connect Web3.js to Polygon or Ethereum or Silo, Avalanche, even Filecoin. If I'm not mistaken, Filecoin also has a RPC endpoint. To get those RPC endpoints, normally I always use chainlist.org. And then if I go here, I will click in Ethereum mainnet, and then I can get this URL, is llama RPC, and then I will put it here. And basically right now we are connected to Ethereum, and then I will show you, I will prove you that we are connected to Ethereum. So what we need to do is just to type web3.eth.get maybe chain ID. You can use that one. And then it will just return the chain ID. Then I'm just going to console log the result. So if I run this node index, we get the result chain ID 1 because the chain ID of the Ethereum mainnet is number 1. And then, for example, if I switch to base, and then I put a RPC endpoint of base, and then I run this again, we are getting a different chain ID because now we are connected to base. So basically, just by changing this RPC URL that you see here, we are able to interact to different networks. So in this case, we are going to interact with Sepolia. So I'm just going to look for Sepolia here. So now we are connected to Sepolia. And then if I run this, we can see the chain ID that is connected to Sepolia. Perfect. So basically like that, you can get started using Web3.js. You will always need to type web3.eth and then dot, depending on what you want to do. Actually, for this, I will go to a different slides because then I want to give you like a better intro to this Web3.js. So maybe it can be this one, August 24th. Then I'm just going to copy paste some of the slides that I have here. Yeah. And this will be a great reference. Okay. Perfect. Okay, so let's start by fetching data. So the first thing that we are going to do is to fetch data from the blockchain. Since I know that most of the people here could be like a React developers or front end, so I'm just going to create a React app. npx create React app. It's Nigeria. Now we can just wait until the app is created. Taking a while. So, and then I'm just going to show you how to do everything from the front end, interacting with React, which makes more sense. Let's wait a few minutes. Let's take a while. And then we see how to create a byte. Create byte. Byte will be a name create. It's just crashing. Jesus Christ. We'll just open a new terminal, then I will create a byte app. Then byte project, React, JavaScript, then install. So yeah, I'm just installing Byte because that's faster than React, so it would be better. Now let's open this in the browser by just running npm run dev. Yeah, that's Byte. That's faster. Yeah. And then we have it in localhost 5173, and then we have here the Byte app. So what are we going to do is to use this Byte app to interact with Web3.js. So the first thing that we need to do is to install the Web3 library inside our app. Then I will come here, and then I will delete some of the things that are here. So I React. Then I can remove this. Okay, so basically we just have now like a button in our Byte app that we are going to use to always do something here. And then we have also use a state from React that I will use to just show something, because I'm going to do a lot of different use cases. Show something. Okay, so the first thing that I want to do is to fetch data from the blockchain. So fetch data on the blockchain. So the first thing is to import the Web3 library. Then after we import the Web3 library, then we need to initialize the Web3 library, Web3 module. So const Web3 equals to new Web3. And then here we need to type window.ethereum because now we are connecting the Web3 library with MetaMask. So that's why we just put window.ethereum. And then here we can start using the Web3 library by typing, for example, web3.eth.get log number. Then we can just put const results, wait, set show something, and then we can just show this in the front end. Maybe here. So show something. Okay, I don't know why my app is crashing right now. Let's see if I have an error. And okay. Okay, so far what I did basically was just created this app, is empty, and I just have a button and I just have a result, and we are going to print the result here with little actions that I'm going to trigger with Web3.js. So this function will do something, and then we are going to show something here. As you can see, I have that here. This button is calling this function, and then here we are showing the result. So in this case, if I click in the do something, what we are doing is getting the latest block number of the network. So let's try this. If I click here, let's see, I'm connected in this case to Sepolia. And then if I click and do something, this is returning the latest block number in Sepolia. And then if I connect it to Ethereum, and I click here again, this is returning the latest block number of Ethereum, and so on. I can just change my network here in MetaMask. Mumbai, I click. Mumbai didn't work. Oh yeah, Mumbai is loading. If I switch to Polygon, and then I click here, now it's fetching. Oh yeah, now it's fetching the latest block number of Polygon. So basically, just like that, you are connecting Web3.js to the network of MetaMask. Okay, and now let's go back to the slides. The second thing that we can use is the Web3 utility functions. So to use the Web3 utility functions, instead of typing web3.it, we just need to type web3.utils. And then here we have all the utility functions that we can use. In this case, I will use maybe to weigh, which is a really common function, to convert, let's say, ether or any other unit to weigh, because weigh is 10 to the power of 18 ether. So if I want to convert 1 ether to weigh, this will be 1 with 18 zeros in the right. So let's just click here, and then let's see the result. In this case, this will be convert 1 ETH to weigh. So if I come back to the dApp, if I click convert 1 ETH to weigh, this is showing 1 ETH in weigh, which is with the 18 zeros to the right. And that's how you can use the Web3 utility functions, just by typing web3.utils dot, and then the function that you want to get. Then you can do different things, different conversion, parsing units, etc. Then let's do now something more fun, which is creating a wallet. So what I'm going to do is to ask the user to connect a wallet. And to do that, what we need to type is web3.it.request_accounts. And what this is doing is it will just pop up the MetaMask. It will ask the user to connect one account. And then it will return an array with the accounts that the user connected. So let's just also show something here, accounts in the slot 0, because this is an array with different accounts. And then let's see if this works. So I will change the button, connect your account. Let me just first disconnect in case that I'm connected. Okay, no accounts connected. So if I click here, MetaMask is popping up in the right. It will ask me which account do you want to connect. I choose this one. I click in next, confirm. And then here is updating the address that I just connected to this app. And then after we have connected the accounts, we can send a transaction. So to send a transaction, we can send different types of transactions, but then in this case, I'm just going to send, let's say, 1 ether. So to send 1 ether, let me show you the different fields that we have in a transaction. We have from, to, value, nonce, gas limit, etc. But for Web3.js, if you want, you only need at least the from and the to. And then depending on what you are doing, you can do the data or the value. So let's just put from, to, and value, because we are sending value. Okay, so in this case, I'm going to send 1 ETH. So to send 1 ETH, this is what we are going to use, the Web3 utils. because this is always the value in way. So basically we are sending here this value, something like that, with 18 zeros. Then we are sending this from the account that we just connected. So that's why I will put this account in the index 0. And then we are sending this to, let me just choose one account that doesn't have ETH. Sequoia. Maybe this one in Oxford. Okay, so what we are doing is this account is sending one ETH to this address. This account is receiving one ETH. And then the value that we are sending is one ETH that is equal to 1 to the power of 18. Perfect. Okay, so I'm just going to the app again. I'm going to disconnect my account. Then I will click in connect your account. I'm going to choose, first let me just change the network to Sepolia. Then I'm going to connect my account, this Lagos account, which has 4.96 ETH. Then we are going to send one ETH to ETH Oxford. Let's see. Oh, yeah. So now we just connected the account. I just created a transaction, and then we need to send the transaction. So to send the transaction, we just need to type Web3 ETH.send transaction. And then here we just type the transaction that we just created here. It will return the transaction receipt. And then I'm going to show the transaction hash once the transaction is done. So let's try this again. I will disconnect my account. And then this should do 2 steps. One is connecting the account and one is sending the transaction. So now it's just connecting the account. And now it's sending the transaction, which is one ETH. You can see the value here, -1, which is sending it to the other account. I click and confirm. And here we'll update the transaction hash when it sends the transaction. Then if we go to Sepolia scan, Sepolia Itra scan, we put the transaction hash. We can see that we send from this address to this address one ETH. Perfect. So that's how we can send transactions. This is how we connect the accounts with this line of code. Just await web3.eth.request accounts. Then we created the transaction. And then we just send the transaction that we created with web3.eth.send transaction. Let's see what else we can do here. Okay, now let's interact with the smart contracts. So to interact with the smart contracts, we will always need an ABI. The ABI is just an interface that JavaScript will require to be able to call the smart contracts. So in this case, I'm just going to use the ERC20 ABI. And this ABI will work with all the ERC20s because they have the same ABI. Just going to create ABI.mjs file here. So I just copy paste the ABI that I found online. I just type ERC20 ABI. I just pasted this here. I'm going to import the ABI in the app. Where I am. Assets. What's my ABI? Oh, it's a site. Like for this ABI, getting assets. Okay, so like this, we are putting the ABI in the assets. We are importing it here. And then what we need to do is to initialize the contract. To initialize the contract, we just need to type new web3.it.contract. We just pass the ABI as a parameter and then the address of the contract that we want to interact with. In this case, I have the ERC, the USD token. So we are going to interact with the USDC. I just copy the address here, which is this one. We assert the contract instance here. And then to interact with the contract, we just need to type the contract instance, which is contract.methods. And then the name of the function that we want to interact with. In this case, it will be name and then .call. If you want to interact with more functions, so then you just need to change here the name of the function that you are interacting with. Then let's just start using different variables. Let's say 1, 2, 3. And then let's see what is the result that we get. So we are interacting with the contract to fetch the name of the contract, the decimals, and total supply. Then let's see if this works. Set show something, put a string, to a string. Okay, so then let's try and see if it works. We get that error here. Oh yeah, so what happened here is that I'm connected to Sepolia, but we are interacting with a contract that is in Ethereum, right? So we need to change the network. That's really important to always be connected in the same network of the smart contract that we are calling. So now I'm connected to Ethereum, and then if I click here, then we get the USD coin. And then if I show the console, we get USD coin, 6N, that is the number of the decimals, and then the total supply, which is this. So that's how we can interact with the smart contracts. Okay, and then the last thing that I can show you as well is how to interact with the smart contracts, but to send transactions. So in this case, I have this smart contract that I deploy in Sepolia. And what this smart contract does is you can only set a message, and then that message will be written here in this message variable. And then the other function is just to get the message. So basically, this smart contract only stores a message, and then you can just change the message that you want. So we are going to interact with the set message function and also with the get message function. So the first thing that we need for this is the ABI that I will copy from here. We'll just remove this ERC20 ABI. Okay, now we have the ABI. Now we need the contract address here. And just like that is how we can initialize the contract with the ABI and the contract address. Here we are asking the user to connect an account. And then here, instead of putting .call, you need to type .send. Just remove this. So contract.methods.set message, and then .send. And then here we just create an object specifying who is sending this transaction, in this case, the account in the index 0, which is this one. And then this will return the transaction hash here, sit, and then we can show the transaction hash. Yeah. Here in set message, we need to set a message. So in this case, I can just say hello, ETH Nigeria. So let's just try to call this. Oh, first thing is to switch the network to Sepolia. But we are interacting with a contract that is in Sepolia. So I just need to switch to Sepolia. And let me just update the name of the button. Set message. Then when I click there, we are just basically interacting with the smart contract that is here with this function set message. So I just confirm. We go to the contract and we click here in read contract. We will see the get message function. Then this was the other message that I said a few days ago. Hello, Lagos. But now if I just fetch the latest message just by typing contract.methods.getMessage.call, this will return the latest message. And then we can just show here in the front end. Yeah, now let's try this. So as you can see now that I click in send message, then we are getting the hello ETH Nigeria. So that's just the latest message that we sent. And that's how we can interact with the smart contract. So here, this is an example to interact with writing functions. And then this one is an example to interact with reading functions. Because the smart contract only have those two types of functions. Then if you want to interact with payable functions, which are also writing functions, the only thing that you need to change is to add the value here and specify how much value do you want to send. In this case, can be the ETH or Sepolia that you want to send to the smart contract. Okay, so I think this is the most important to get started with Web3.js. And now we can start creating a plugin, which is kind of important as well. So to create a plugin, let me just close this. We'll start a new project. Then npm init -y. Then we see the package.json. Then npm install web3. And then we can see that the web3 library is here. So what we need to do is to create a index.mjs file. And here we are going to create the plugin. So to create the plugin, we only need to import the Web3 plugin base module from the Web3 library. These plugins are really good because then this will allow you to participate in the bounties, hackathons by creating developer tools. So today we are going to create a developer tool that will allow you to interact with the StarNet, CK-Sync, Polygon CK-EVM, and I think another one, Arbitrum as well. Yeah. This is how you create the plugin. You just import the Web3 plugin base. Then you need to create a JavaScript class, which extends from this Web3 plugin base. Then after that, you need to add the property plugin namespace because this will be used for the final developer user to interact with the plugin. And then you are able to start doing whatever you want, implementing the plugin and everything. So let's start by creating the class. Stored call class. Let's call it Nigeria extends Web3 plugin base. Then we need to add the plugin namespace, and then let's call it Nigeria, lowercase. And then here we can start like putting all the different methods that we want to implement. So let's start with Arbitrum, maybe. Yeah, maybe Arbitrum. So remember that we have this JSON RPC API for Ethereum, but then what happened with some of the layer twos is that they have different APIs. So sometimes when you want to interact with Ethereum and then you want to interact with Arbitrum, they have something different. So you are not able to use any JavaScript library to interact with these layer twos, except if they have like an SDK. So with this plugin, you can basically create an SDK to interact with all the layer twos as well. So we are going to interact with Arbitrum. Let me actually go to Ethereum JSON RPC so you're able to understand a little bit more about that as well. When we go to the API of the Ethereum JSON RPC, we can see all these calls here: ETH get balance, ETH get code, ETH gets transaction count, etc. Then we can see more here: ETH block numbers and raw transaction. So what happened is that if you try to call, let's say, Arbitrum with all these ETH JSON RPC APIs, it will work. But then if you try some of the other custom RPC APIs from Arbitrum, it will not work. So in this case, Arbitrum has something that is called nitrogenesis block. And to be able to fetch this, you need to send a custom RPC API. So that's what we are doing now, sending custom RPC APIs to interact with different layer twos, or even with different networks, like for example, Solana. If you try to call Solana by sending the method ETH call, it will not work. But then you can send a specific Solana method and then it will work. So I'm just going to interact here with Arbitrum. To be able to send like a custom RPC methods, we just need to type this.requestmanager.send. And then this method, this object will have two things: the method and the parameters. So in this case, the method that we are using to interact with Arbitrum is a ETH call. But then in the parameters, we have two different things. One is the tool that we are interacting with this specific address. And then the other one is the data. So for the tool, if we go to the Arbitrum implementation, it says that you need to send the RPC call to the contract available in the address 0xC8. But then to be able to call the 0xC8 address, you need to pad the whole address with a lot of zeros. So you need to use web3.utils. Oh, sorry, this, we can import the utils here. And then we can use utils dot path right, I think. Then it would be 0xC8. And then we can put 40 because we want this string to be 40 characters length long. So what we are having here is 0x0000C8, something like that. And then for the data, we are interacting with a function that is called nitrogenesis block. So to interact with this nitrogenesis block, we need to use the ABI, the ETH ABI package. So we just use ETH.ABI dot encode function signature. And then here we just send the function that we are calling. In this case, it's nitrogenesis block. Nitrogenesis block. And then this will return something. And then let's just print it in the console to see Arbitrum, to see what is the result. Then let's just create another file to test the plugin. So testing plugin. Then here we will just import the plugin. Import the Web3 library. Then just we need to initialize the Web3 module with a Sepolia with an Arbitrum RPC because we are interacting with Arbitrum. So I will go here. And then here we can use the plugin. So to use the plugin, what we need to do is first register the plugin by typing web3.register plugin and creating a new instance of this plugin. So new ETH Nigeria. And then we can use the plugin by typing web3.ETH Nigeria. So to use the plugin, we need to use this plugin namespace property, which is ETH Nigeria, everything lowercase. So that's why that name is important. And then after the web3.ETH Nigeria, we put the name of the method, in this case, arbitrum.arbitrum. And then let's see what we get here when we run this. Node testing plugin. So we are getting a 0x result. And let's see. Because maybe we are calling the wrong function. We are calling the wrong address here, this 0x. Let me just put it manually. And then let's call this again. Yeah, and then we are getting a result. So the result that we are getting here is based on the Arbitrum implementation. This will just return the first block produced using the Nitro code base. We don't really need to care about that. The main thing is just to create custom RPC calls that allow us to interact with different layer twos. So here we just created a custom one to interact with Arbitrum. Then we can also use the utils to pick int to format this in a nicer way instead of this long hex string. Now we just show this in a nice number. And that's how we can interact with Arbitrum, sending a custom RPC call. Now let's interact with the second one, which is startnet. So I will create a function called startnet. So in this startnet, what we are going to do is just to get the startnet chain ID. Let me show you the implementation of the RPC of startnet. So when we go to quick notes, you can see that startnet has different RPC calls, like a startnet underscore and all these things. If you try to call Ethereum with one of these, it will not work. This will only work with the startnet. So what I'm going to do is to create a custom RPC call. So this .requestmanager.send. Then this receive the two properties, methods, and parameters. So the method that we are calling in startnet is called startnet underscore chain ID. And this doesn't receive any parameters. Chain ID. Then this will return the chain ID that we are going to print here in the console. Chain ID, startnet. This will also return the value in a hexadecimal string. And then to interact with this method, we just type web3.ethnigeria.startnet, and then we are going to interact with the startnet. If we run this, we need to change also the provider, because what happened is that we are interacting with Arbitrum, right? So if we are interacting with Arbitrum and we say startnet underscore chain ID, it says that this method is not supported because Arbitrum doesn't support that method. So what we can do before here is this .set provider. And then we can set the provider, kind of set Web3.js to interact with the StarNet instead of interact with Arbitrum. So here in the slides, in slide 34, I have a RPC link to interact with the StarNet. And now let's see if this works. And now this is returning the chain ID of a StarNet. Then we can use again utils.toBigInt to show that in a big int instead of the hexadecimal string. And then here is the result of the StarNet. And this is the chain ID of the StarNet. And then what we can do now is to interact with CK-Sync as well. So I will do the same, interact CK-Sync. First, we need to set the provider to tell the plugin like, hey, when you interact with the CK-Sync method, I want you to interact with the CK-Sync network. So then we need to set the provider with the CK-Sync RPC URL first. And then we can send the custom RPC method here. This.requestManager.send method and then params. In this case, the method is called CKS_getFeeParams. And then it doesn't receive any parameters. And then we can just show in the console the CK-Sync feeParams. So then let's try to run this. Let's call it here as well. So as you can see here, we are still here interacting with the StarNet, here interacting with Arbitrum. And then in the third one, we are interacting with the fee parameters of CK-Sync. So I just want to show in this case .b2 .l1 gas price, for example. Then let's see what we get here. Perfect. So we get the chain ID of a StarNet, the CK-Sync fee parameters here, and then the Arbitrum here as well. So basically, we are just creating the plugin and allowing the developer. At the end, the developer that uses our plugin is using this web3.itnigeria.arbitrum or .starnet or .ck-sync, and we are implementing all this logic behind the scenes for the developer to be able to use that. And then the last one is Polygon CK EVM. So for the Polygon CK EVM, what we are going to do is to check in the layer 2 of Polygon to see if a block was already verified in the layer 1. So to do that, we need to call the CK EVM underscore is block consolidated. So let's create that. And then this will return true or false. This.requestManager.send. Remember that this is how we can send custom RPC calls. This.requestManager.send. Then we just create an object with methods and parameters. So in this case, the Polygon CK EVM method is this one, CK EVM underscore is block consolidated. This will receive as a parameter a block number that we want to check. So we can just put it here, block number. And then we can print the result. So the block is block consolidated. So first we need to set the provider here as well to be able to talk to the Polygon CK EVM. And then we can just use this here as well. Polygon CK EVM. Then if we run this, oh, I forgot to send the block. So here we need to send a block. So let's say that I send the block 100,000. And it says that it's block consolidated true, but then let's try to send like a latest block to get a false. So if we try to check the latest block number, which is this one, it should return false because it hasn't been consolidated in the layer 1. So it's block consolidated. We are getting the false. Let me just put it here. We can check that this block number is not consolidated. But then if we try a different block number, like maybe we just remove 1 digit, then we can see that this block is consolidated. So in this case, the importance of these Web3 plugins is not even the functionality that we are doing. Like, we don't really care today about this block consolidated or about the chain ID of Starnet, etc. But it's more about the capabilities of what you can do with a Web3 plugin. And then any developer will be able to use your plugin just by calling these methods like this. But then I will show you the fun and the latest part, which is, okay, I already create a plugin, and then what can I do for other developers to use my plugin? So what you need to do is first, you need to go to the package.json. You can put a nice name. So let's say it Nigeria test. In the main, we need to specify the main file that contains the plugin. In this case, mine is index.mjs. But if you call it in a different way, so put here the name of the file. And then what we need to do is just to type npm publish. And basically we just publish the plugin right now. We can go to npm js.com/package/is Nigeria test. I think I call it like that. Yeah, just need to put the name of the npm package there. And then our plugin has been published here. So as you can see here, a few seconds ago, I just published this. And then we can add a README as well to have like a simple, let's say, getting started guide. If you are creating a plugin or a SDK for a project, so you better create like a good documentation here. And then I am just going to copy paste this as an example to show you what you are showing in the front end. In Nigeria test. And then I will just come to the package.json, update the version, and then I can just publish again, npm publish. And then I can come to the plugin, I can refresh this. And then we will see that the version 1.1 has been published here. And then the getting started guide is here as well. So that's basically how you create the plugin. Then you just publish it on npm, and then anyone will be able to use this plugin. So now you can just run the npm install it Nigeria test. Let me show you, for example. Test. So I just created a new project here just to show you that now I can use my plugin that I just created. So first thing is npm init-y to create the node project, then npm install web3. And then after I install the web3 library, I can install my plugin that I just published a few seconds ago. So npm install it Nigeria test. And we can see that here we have the ETH Nigeria test and also the Web3. And now we can just create a file to test our plugin. So to test our plugin, we need first to import the modules. So import Web3 from Web3, import ETH Nigeria from ETH Nigeria test, initialize RPC. In this case, we need to initialize the RPC with the Arbitrum. So const Web3 equal to new Web3. And then here we have the link to the Arbitrum endpoint. Then we need to register the plugin. So web3.register plugin, then new ETH Nigeria. And then we can use the plugin by just typing web3.ethnigeria.arbitrum, web3.ethnigeria.ckSync, web3.ethnigeria.startnet, and the last one, Nigeria.polygon CK-EVM as well. Then if we run this, let's see if it works. Oh yeah, here I didn't send the block that I wanted to consolidate. Check. So basically what we did here is using the plugin that we just created, which is really easy, just web3.ethnigeria dot the method that we are using. And I think that's, yeah, I would say that that's basically everything. Those are like the main things that you can do with the plugins. The main functionality is just wrapping logic or just lines of code into a simple function. So in this case, we improve the developer experience from this JSON RPC request to these Web3 plugins. In this case, web3.ethnigeria.startnet. And then some of the other plugins that we have available, this one is one of my favorites, is the Web3 contracts plugin. Let me open it there. These Web3 plugin contracts allow us to interact with all the smart contracts that are verified in Etherscan without sending the ABI. So we don't even need to send the ABI to interact with these smart contracts. So let me just show you a quick demo of how this works. First, we just need to install the plugin. So I'm going to install npm install web3 plugin contracts. Going to open this. Then I will import the contracts plugin. Import contract plugin from web3 plugin contracts. Then here we need to register the plugin, web3.register plugin, new contract plugin. And then here we need to send the API key of Etherscan because this plugin is interacting with Etherscan. So I will come to my Etherscan. Then I will come here to API keys. What's this? Then I have this API key here that I will send in the constructor of the plugin. And then we can use the plugin. In this case, I'm going to interact with the USDT. So first thing that we need is the smart contract address. So USDT address is this one. Then after that, we can use the plugin by typing web3.contract plugin .contract. And then this will only receive the address of the contract that we want to initialize, in this case, the USDT. And then we are going to store this in a variable that I will call contract. And then we are able to interact with USDT basically just by sending this address. Maybe let's just call it the name. So contract.methods.name.call. Then the same with the decimals and total supply. And also we can use the balance of, and we can check an address. Maybe I will check my own address to see if I have some USDT. Then we can store this in different variables. So let's say R1, R2, 3, 4. And then we can just print this as well. R1, 2, or 3, or 4. And then let's see if this works. Now index.mjs. Oh, invalid API. Oh yeah, because we are interacting with Arbitrum, and we need to set here an Ethereum RPC instead of Arbitrum, because we are interacting with Ethereum. So I will just send this one. And then as you can see, we just got the name of the contract, which is Tether USD, then the decimals, which are 6, then the total supply, which is this one. And then we also got the balance of, which is 0, because I don't have USDT. So how you can, that's how you can also use the different plugins. And yeah, there are also more plugins that we have that you can explore in the website, web3js.org/plugins. Then you can see here all the different plugins. We are also having some bounties right now for building dApps using these plugins. CK Sync, the StartNet, Chainlink, etc. And yeah, I think that's basically everything for today. Yeah. I don't know if anyone has any question or something. Yeah, I think that's kind of clear. The recording will be there because I think it's really hard to follow everything, but the recording will be there, so you can just take a look to create your own plugins. And yeah, you can just follow us. And yeah, thank you so much for being here, present. Yeah. Wow.
Thank you, Santiago. That was a really, really insightful session, and we appreciate you being here. Yeah. So once again, this is the thank the ecosystem partners. We'd like to thank it's Safari, the Web3js community, it's Accra, and to the people present, to the audience present, we also like to thank you. So I think that'll be all for today, and thank you for joining.